All right, so things that we kind of but kind of not exhausted, other options, okay? We're still kind of looking into that a little bit. But let me show you another method to do this one using trig substitution. Yes. Okay? The first thing that you could kind of recognize, all right, is, and it's a little bit of a trick, but once you do one of them, you can kind of understand it.
Did we just break math?
I don't know. If I could make one of these sides of a right triangle be the square root of 16 minus x squared, if I would call this 4 and this x.
You're fine.
Should we draw this?
Yep.
Honest mistake.
So then using Pythagorean's theorem, this would be the square root of 16 minus x squared.
How do you know the flags, or are you just telling us?
Well, in order, I wanted to be able to have this right here somewhere on the right triangle.
Wait.
And in order to have that, if I call the hypotenuse 4, because 4 squared is 16,
Yep.
and then 16 minus x squared,
Oh.
and then square root, whatever that is, would be this side.
Wait,
Okay.
shouldn't that be the hypotenuse? Or never mind. No, never mind.
Okay?
Oh wait. Yeah.
Yeah, can
That's
you
good.
go explain what height that 4 and x? That's right.
I was wanting to draw a right triangle that would have this, the square root of 16 minus x squared, on it somewhere. Okay? So, this is like your hypotenuse squared, so I made the hypotenuse 4. And then I picked this side to be x, for a particular reason. Okay?
So if you take the hypotenuse.
So then if I do Pythagorean's theorem, call this b, call it a, call it some variable other than x. If you would set that Pythagorean's theorem up, a squared plus x squared equals 4 squared, and then solve that for a, you would get the square root of 16 minus x squared.
Si, senor.
You'll see, I haven't done anything with it yet. Okay? But, everybody okay that this could be a right triangle?
Yes.
Okay? Alright. So now, with that, the sine of theta would equal x over 4. Or I could also then write x equals 4 sine theta. That looks awfully familiar too. There's a lot of similarities.
Is that an arc angle?
What?
Never mind. Nope, I
Okay.
take it back.
Alright. I'm also going to write down the cosine of theta. And that would be adjacent over hypotenuse. And I'm going to move that 4 over as well. So now I could rewrite this using sines and cosines. So x was 4 sine theta. So 4 sine theta. I'm just going to put the squared out there for right now. I could have squared that and just written down 16 sine squared theta, but I'm just showing you how I'm replacing the x. And then the square root of 16 minus x squared, as you can see from the bottom right there, is 4 cosine theta. Now the only thing I have left to replace is the dx, which if I come right here, if x is equal to this, then dx would equal 4 cosine theta d theta.
Oh yeah, because you're
Taking the derivative of both sides with
the
respect to...
antiderivative. Got it. And so then you just put that to the right side.
So then this is, the dx is 4 cosine cosine theta d theta.
Are we going to get to the definite integrals of this?
I don't think so.
That's good, because that sounds like a huge pain changing those around.
So then the four cosine thetas cancel out and you really just have 1 over, I'm going to square this now, 16 sine squared theta d theta. I'm going to bring the 1/16 out to the front. And 1 over sine squared is really cosecant squared. So I brought the 1/16 out, and I'd still have 1 over sine squared then, but 1 over sine squared is cosecant squared. The antiderivative of cosecant squared,
Cotangent.
negative cotangent.
So close.
Close.
Negative cot.
Definitely how you should pronounce it.
And then I can write my final answer. I don't want my I don't want my answer to be in terms of theta because it didn't ask for the antiderivative of this function in terms of theta. It said in terms of x. So now I need to plug in back in terms of x using this picture. Tangent is opposite over adjacent, so cotangent would be adjacent over opposite.
And you need the negative
So I'm just going to replace the cotangent theta with adjacent over opposite.
Yes, because
Yeah.
it's indefinite.
Yep. So negative 1/16
It's a fair question.
times the cotangent, so adjacent over opposite. And then plus c.
The fun has been doubled.
So the whole idea is to draw a right triangle, that could somehow have that square root of what you're looking for on it. You just got to choose the right numbers. I mean, really, you just got to choose the right number for the hypotenuse. And I probably, from what I'm seeing so far, I've been okay just putting the x over there on the ones that I've done.
Couldn't we just do the A, like, you know how we do the A value, the X value, when we do our arc sine, arc sin? Couldn't the A value always be the hypotenuse, and then that X would just be that, and then whatever's left over would be that.
Yeah.